So if I run this cell, loading my domains, and I'm also loading the gold variable. I'm getting the gold variable from the list of variables provided by the domains, because domains was initialized with the gold variable. Another way of doing it is doing parse u. So that's probably a more transparent way of doing it. I'm gonna go ahead and close the project parameters for now, and we can get back to it if it becomes important. So moving on, load and visualize the data. So the first thing here is specifying a data folder. You might be wondering where did that data folder come from, because we didn't have any data here initially. So back to the parameter file, if I go to the very end of it, there is a section of code that we are saying here that can be ignored. This little piece of code, what it does is to just load some example data from the RMSP library and save to this data folder, so we can pretend that's our data, or that's the data that we had in there. So if I load this, if I open this folder, I see we have a STL file, which is a grade shell. I have a CSV for blast hole data, and I have a CSV for exploration data. All right, so back to the workflow. Here I'm loading the exploration data from the CSV file. For that, we use read CSV from the Pandas Python package, and we are loading it as a point data. We specify some metadata, drill hole ID, X, Y, and Z coordinates, and the columns for from and to variables. So if I run this, we can inspect the data. We see all the columns. We have copper as well in this data set, but we are most worried about the gold. Next, we are loading the blast hole data from the bh.csv file. In this file, we have the drill hole ID column, bh ID, and the X, Y, and Z coordinates named respectively. So we can run this cell and take a look inside the data. Yes, we have the columns we specified for metadata. We have gold, silver, and copper, and some geology codes. In this case, we are only interested in gold for this workflow. You may have noticed that within this workflow, we are already loading data that has been desurveyed and composited. There is more detail on how to do that on the Introduction to RMSP series. So if you're interested in reviewing how to desurvey and composite, I do recommend you to go check out that video. So next on this notebook, we are loading the solid for the gold shell using the rmsp.solid from STL. So this function is gonna load STL file formats, and if I run that, shell is now my solid. Next cell, we have the contains function. This was also covered on the Introduction to RMSP. Basically, this function is used to flag any spatial object, grids or composites, for instance. In this case, we are running that on our exploration composites. So if I look at the output of this function, it is just a Boolean array with false if it's outside and true if it's inside. If I want to convert this to integer codes, I can do that by using as type and then int, and this will convert trues to ones and false to zeros, and that will match our domain codes. We have code 1 for inside and 0 for outside. We are assigning the output to the domain column, and we're doing that for the exploration composites and for our blast holes. So if I run this, I flag, and then we can see the content of that column with the describe function. This just gives us some statistics. We can see that 26% is coded as inside the shell for the exploration data, and 24% is coded as inside the shell for the blast hole data. Every time we perform some flagging, it's good practice to perform some visualization and check if the flagging is correct. So for that here, what we're doing is to visualize in 3D some of our data, starting with the expiration composites, and we are adding a viewer with the gold variable and the flag domains. For the blast hole, we are adding it to the viewer that was created above, or also the gold variable and the domains. We have some controls on how it looks like, and we also have the shell, which is actually missing a label. So grade shell. So let's see how it looks like. We can check the flagging first for the blast holes and the expiration data. So everything inside the grade shell looks to be colored properly, and we can take a look at the grade itself. That's good. So now that's our expiration data, our blast hole data, and our solids. So one thing that is now relevant is this commented line of code that I have above. So if I want all my 3D views to be shown as static instead of interactive, what I can do is to uncomment this line of code and run that. So this is going to change the global parameter that controls the static views to true. And now if I go down to my viewer, instead of generating a active 3D viewer, it just generates a figure, which is the static version. So in sometimes you will want to have static views instead of interactive views, and that's how you control that. In order to reverse that, I have to actually set it to false and run again, and only now I can comment that cell back. So if I rerun this now, I should now have access to the interactive viewer.